Hey, patch day 26, and today I'm going to look at a technique that I invented, although I'm not sure that it was really just mine. Back in 2001, there's a paper written all about it called, what's the paper called? Temporal Filtering, Framing Sonic Objects. Amazing. Um, and I guess all of this stuff down here is what I'm going to do today, which is essentially poking sound file stuff into a buffer according to its spectral analysis somehow. It's kind of a bit, yes, experimental. Maybe you can use it to impress people. I don't know. I'll just create a buffer to start with because that's where I'm going to want to store all of this stuff. And it's going to want to be a really huge buffer. I'll make it 320,000 milliseconds long. I've probably said this before, but that value that you put in this buffer pretty much depends on the amount of RAM you have. It will allow you to create a buffer that's larger than the RAM, but then it starts reading and writing to what might be called virtual RAM, but I don't know if that's what it's called anymore. All right, very good. So let's just see if I create something to catalog. So we're going to use an SF play, new SF play. Again, this file is going to want to be longer than any of the stuff that comes with Macs. So we're going to use the Dropbox here, a drop file thing with a prepend open. Hello, prepend open with a drop file, and that's on the palette. Looks like that. You probably seen me do this before. New drop file. Yes, indeed, everything is an object. The world is full of objects. And then we open this file, and we're going to analyze this file using an FFT. So I'm using FFT in the open, so to speak. It's not it's not in a PFFT, so it has no overlapping. It's kind of useless in terms of its ability to produce sound that sounds halfway decent. But since we're only using it as analysis, that's great. So what we're going to do is get the magnitude of this thing. For this process, we usually use something called car to pole. It's like a square root of the sum of the squares, which if you know anything about trigonometry, you'll know that gives you both an amplitude output and a phase output. And some kind of logic on that, just to see if it's greater than, let's say, 1. We're going to look at this on a frame by, on an index value. So this is where we're going to use the index from here, and we're going to add 1 to that index because an index of 0 is not going to be very useful for what we're going to do next, which is stick it through a gate tilde. So I'll make it gate tilde. And we're going to make a gate with, let's say, I don't know, 14 outlets. And we're going to look at the first 14 values coming from the FFT as to whether the amplitude, magnitude, I guess is the word for it, is greater than 1. All right. And on each one of those things there, sorry, that was not what I meant to press. And each one of those things there, we're going to check. We're just going to basically see, using an edge, if it has gone over, if this was greater than 1 on this time around, then we're going to trigger on 0 to non-zero transition a message that will be, in this case, 1, but let's just see. Well, actually, what I'm going to do for this is make it a subpatcher. So I'll make a new subpatcher with an inlet, which looks like that. And I'm going to say new with an edge tilde. Whoa, it's not an edge tilde. And I'm going to trigger out a number that I'm going to want to put into the outside world. So I'm going to make a message with the argument, with the message dollar, what is that, #1. When you make a message #1 in a abstraction like this, you can then change that number on the outside world. And I'm going to send that to some kind of receive. I'll call that receive pants somewhere in the main patcher. All right, so I can save this somewhere where I'm going to remember it. Where documents, I don't know, where YouTube, new folder, garbage, I don't know. Okay, can call this, what will I call it? I'll call it stuff. That's probably not going to tell me much in the future. Okay, fine, stuff. And then out here, of course, again, if I make something called stuff, it probably doesn't know what it is. It'll have the error message in the Max window saying stuff is no such object. That's because I need to save this in the same place. Save as, and we'll call this, this is the word, the name phrase I use to describe this process, Spectral catalog. Whoa. Okay, so now it should recognize stuff. And I'm also going to want to give this a separate number for each one, so that each time, for each one of those first 14 bins in the FFT, it'll trigger out a different number according to which bin is triggered. And I'm going to do these in power of 2 so that when I accumulate those values, which we can already look at that, so that maybe that makes some amount of sense. Every time this thing gets to a, crosses the 0 crossing, so I'll use an edge on this, the index value, and I'm going to have the thing that's coming from all of those subpatches, which was pants. I'm going to accumulate those, so I'll make a new object, accum. I'm going to accumulate all those values, and every time I get a transition from non-zero to 0, which means that this ramp, this index value, has then dropped to 0, which is a good time to get this value out of the accum. The way you get the value out of an accum is to bang it, so I'll make the message bang, and then after I've got that value out, I'll probably want to set it back to 0 so that it will accumulate from the start again. So we can hook that up. And because this FFT is 512, I'm going to multiply that by 512 for my index before I poke it into this buffer called scoobs. Alright, this might not be making any sense. You can read the paper if it doesn't make any sense after I get to the end of this tutorial, this patch a day. I'm going to add this 512 multiples of 512 by the index to poke the sample data in. So let's make that just a new object with a plus tilde. This plus this. Very good. How can I make this look neater? Okay. That's very good. That's going to be the index for my poke. All right. So these are going to be in powers of 2 for reasons that I'm probably not quite able to tell you right now. But stuff 2 will be our next one, and then the next couple are going to be stuff 4 and stuff 8. The reason for the powers of 2 is because I want each one of these to produce a unique number, so that each spectral, each time the spectrum is different from another time, it will be a unique number. I don't know how many other ways of saying that. So I'm just continually creating these abstractions according to powers of 2. I'm up to 128. At a certain point, I think that's probably why I stopped at 14 on my gate there, is because there's a certain point at which I'm not really going to be able to figure out powers of 2 off the top of my head. 1024 is next. 2048. I'm still good. I can still recite my powers of 2. And keep looking this up. There's probably a much simpler way of doing this. We just need a couple more at the end here. And those are 4096, which I can still do. And then the last one, 8192. Let's just believe it. All right. Go in there, go in there. All right. Very good. The next thing I'm going to do is to hook up the SF Play to index into the poke. I could do that just directly. A couple things I might want to do is to delay it, because it's going to be what I'm actually analyzing is one frame behind what's happening in the real world. So I'll give it an 11 millisecond delay with a tap in, tap out pair of 11 milliseconds. It's slightly different than 11 milliseconds, but you know, close enough for jazz, as they say, or I'm not sure if they still do say that. And the other thing I'll do is to make it so it's windowed, and I'll just use this frame index as a way to read a window. Again, I can find the window function back down in my Max folder. We've already done this in one of the patcher days. In the examples, Max 5 examples, FFT fun, no, it's effects, transposer, and in the lib there's a transposer, and somewhere in here, this little guy here, P window, generates a nice looking window that we can see here for doing amplitude windowing. I'm going to copy that and paste it. So that's just automatically generated the window. Perhaps we might have to close and reopen the patch if it didn't. So that I can now make an index tilde with the argument window, the same as the name of this buffer here. Yes, which actually this little set message will do that. So let's just give it, you have to give it something. So, okay, it's dash dash, I mean not underscore, but dash dash window. Verify that that's in there by double clicking it. Nope, didn't find it. Fine. Hook this up, open this up, and set that. And yes, indeed, now my index tilde has that value. All right, I'm going to use this index here from the FFT to read the window, and I'm going to multiply my amplitude of my sound by this window function here and poke that into my buffer called Scoobs. The last thing I need before I totally lose my mind is I need a DAC to play things back from. So there's my Easy DAC, SF Play out to the Easy DAC. I just need that mostly just to make this thing work, because of course it won't work unless audio is running. And I guess I'll probably want to hear the results, and so let's just create something real quick to play back the Scoobs buffer that I'm going to write to play on the Scoobs. A line tilde with a message coming into it. Message. I guess actually more things that are interesting are stored later on in the buffer. So I'll go from 200,000 to 320,000 over 120,000. Yeah. But when I'll need to drag a file in here as well, and I'm going to go back to where I downloaded in Patcher Day 21, I think it was, all those Patcher Days ago, this file that I stole from Freesound. So that's good. So now when I start the playback, which again I need a toggle for that, I'm forgetting all sorts of stuff here that's important. When I start the playback on this, it should be writing values into this buffer. You can't really see it while it's writing things in because something about poke makes the buffer go a bit crazy. We'll see, unless I've made a mistake here and nothing's going to work at all. But yeah, you can see slowly some of this buffer being filled up with sounds. What can I say? There's not really anything sequential about the way that the samples are being stored. There's more. It's more like it goes from obviously the lowest bin, the first bin, or the zero bin, if you like, is going to be where all of the lowest. When this is triggered, it's going to be lower frequency. Obviously, that means that low frequencies are going to be more quickly updated or more closely connected or more closely placed in time than the higher frequencies, which are going to be a sort of a minimum of 8192 times 512 apart in samples, and whatever that value is, I have no idea. And then louder things are going to be more towards, because they're going to satisfy the logic on all of those, they're going to be towards the end. So it's kind of a spectral cataloging where the catalog is kind of meaningless, but it produces some interesting sound results, I think. You might think it's just totally blind. At some point, you probably want at least an hour of music or sound coming into this thing to get a good catalog. I can turn this off and hear what it's got going on. Not very much. But anyway, it's something to play around with. It's an idea. You can think about how to grab the stuff that's stored according to an analysis of a second sound. That's something I've played around with a little bit. That's something to think about anyway. And this is the end of this patch a day. Bye.